For decades, software functioned as a static artifact, syntax typed by human hands and fixed once deployed. By 2026, these codebases operate as living ecosystems. We have already moved through the early stages of automation, progressing from level 0, manual typing, to level 3, AI copilots, where agents generate functions and files for human review. This chart maps the stages of engineering autonomy. In 2026, the industry is crossing the threshold into level 4, high automation. At this level, codebases are self-driving, capable of generating and maintaining their own structures with minimal oversight. Crossing this line shifts the software lifecycle into a machine-driven operation, where the system is responsible for its own internal state and evolution. A hierarchical multi-agent architecture serves as the brain for these autonomous systems. The route planner receives a high-level business objective and immediately decomposes it into a tree of executable subtasks, delegating each piece to specialized worker agents. This engine can coordinate hundreds of agents simultaneously, sustaining a throughput of roughly 1,000 autonomous commits per hour. At that speed and volume, a traditional system would collapse under its own bugs. How do these agents avoid creating a chaotic mess of technical debt? The system treats individual errors as expected events. If an agent fails, the orchestrator detects the broken branch, reassigns the task, and continues execution. Resilience is built into the architecture. These systems achieve that resilience by acting like an organism equipped with an immune system that actively maintains its own health. This self-healing pipeline operates in distinct layers. First is reactive healing. When errors occur, agents capture logs, generate a patch, and deploy a fix without human intervention. Next, predictive healing analyzes anomaly patterns to identify and preemptively refactor vulnerable code before failures manifest. Agents address technical debt in real time, managing it as a continuous operational condition rather than letting it accumulate as a deferred liability. This shift requires a transition from traditional CI/CD to CA/CD, continuous autonomy and continuous delivery. This comparison shows the difference. While a traditional pipeline halts and alerts a human when a build fails, the CA/CD side triggers repair agents to autonomously diagnose and fix the root cause. The most advanced agents use evolutionary algorithms to modify their own source code. By reflecting on their performance and refining their logic, they achieve measurable gains in reasoning and efficiency without human help. The deployment pipeline acts as an active participant in the software lifecycle, judging fitness and correcting deficiencies before any code reaches a human reviewer. When machines write and heal the code, the human engineer's responsibilities shift toward the strategic layer of the system. Engineers now act as intent architects, providing the business context and high-level objectives that guide the multi-agent systems planning. Controlling these autonomous systems requires policy as code, strict machine-readable rules that define exactly what an agent is allowed to do. This model shows how governance boundaries rest on the foundation of intent architecture. These boundaries use security-first principles and financial controls to ensure agents operate safely within defined budget and privilege limits. These policies create a vital cage for the living ecosystem, ensuring the autonomous codebase remains directed and safe. For leadership, this era introduces the AI productivity paradox. Measuring success by the raw volume of autonomous commits will quickly drown a company in complex, self-generated technical debt. Strategic metrics must move toward value realization and strategic alignment, judging the software by its fitness for purpose rather than its lines of code. Human expertise is now concentrated on building evaluation suites and fitness functions. These human-defined benchmarks act as the final judge for all agent-generated output. Self-driving codebases handle the mechanical, repetitive tasks of development, allowing engineers to focus on creative architecture and strategic oversight. The future belongs to those who operate at the highest level of abstraction, steering the extraordinary machine by defining the intent and values that govern it.